topic called naive-Bayes algorithm. So with this, our supervised learning algorithms will be finished. From tomorrow onwards, we will discuss unsupervised learning. So that is clustering algorithms. After finishing clustering, we will discuss natural language processing. That is for sentimental analysis. After finishing that thing, we will start deep learning. In the today's session, initially we will discuss naive-Bayes algorithm. After finishing naive-Bayes algorithm, we will discuss on which cases we need to choose which algorithm. So which is preferable for which cases. We will discuss that thing. So here till now we have two probabilistic models. Out of those two probabilistic model, first one is a logistic regression. Based on the probability, we are predicting the output. For that, first model is a logistic regression, and second one is a naive Bayes. Here we are taking help of Bayes theorem. That's why here we are saying naive Bayes. So initially I will play the video. So after that, I will explain you the program corresponding to the naive Bayes.
Hello and welcome back to the course on machine learning. This is Kirill Eremenko, and in today's tutorial we're talking about the naive Bayes classifier. This is a very interesting machine learning algorithm, and today we're going to get to know it on a very intuitive level. And in line with the super data science mission, which is making the complex simple, we're going to break down this complex topic into... Well, let's have a look. Theorem. And this is something we talked about in the previous tutorial, so by now we should be quite comfortable with the concept. How are we going to apply it to create a machine learning algorithm? Well, let's have a look. Here we've got a dataset. So it has two features. It has x1 and x2, and there are two categories. Category 1, which is red, and category 2, which is green. But instead of working with these abstract terms, we're going to convert them into something that we can understand a bit better, something that's a bit easier to operate with or to talk about. So we're going to call the y variable, x2 variable salary, and the x1 variable is going to be age. So basically we're representing observations or people that are part of our data set in terms of their age and salary. As you can see, we have 30 people here on this chart. And the categories, we're going to replace them with walks, meaning that person walks to work, and green will be drives. That means that person drives to work. And so now we get to a problem, to the machine learning challenge that we're going to be solving. What happens if we add a new observation, a new data point into this set? How do we classify this new data point? So as you can tell, this is a supervised machine learning algorithm because we're classifying something based on previously known classes. And so the question is this person going to be classified as a person who walks to work, or is this person going to be classified as a person who drives to work? And the naive Bayes algorithm is going to help us solve this challenge. All right, so how are we going to approach this? We need a plan of attack. It is going to be quite a complex approach, but at the same time, we're going to break it down into steps and it'll all make sense. It'll be very easy to understand. So our plan of attack. We're going to take the Bayes theorem and we're going to apply it twice. First time, we're going to apply it to find out what is the probability that this person walks given his features. And X over here is the features, or represents the features of that data point. So let's go back to the visualization here. So here you can see that this is our new data point. That person has a certain age. So let's say the age of that person maybe is like 25 years old. And then they have a salary. So let's say their salary is $30,000 per year. So those are features of this observation. Right now, we're only working with two variables, just for simplicity's sake, so we can visualize things, age and salary. But in reality, they could be...
So here, remember one thing. So here, red points belongs to one category, and this blue color points belongs to one category. So here it took the data set based on the job offer. So whether the person accepted that offer or not. So here the person walks means he leave the job. Whether the person drives means he accepted that specific job. So here we have the person belongs at this specific location. That is nothing but the person have age around 25 years and he might have salary like some 30,000. So whether that person is accept that job or not, we need to predict that thing. based on the conditional probability. So at that time, he will explain you how to find that conditional probability by using Bayes theorem, how to find the optimal parameters, and how our algorithm calculate all these parameters at the back end. So in this entire tutorial, he will explain you that thing only.
Many more features. There could be features on how many what industry they work in, or how many years of education they have, or how long they've had a driver's license for, and things like that, of how far away they live from work. So there could be lots of variables, but at the same time, right now we're only going to be dealing with two: age and salary. And regardless of how many variables you have, they will be called, and we're going to call them features. So given the features of X, so given the age of 25 and the salary of $30,000, and we'll talk in more detail about exactly what we mean by features just in a moment. And so therefore this part represents that person that we're trying to classify. What is the likelihood of a person with those features X? So we know that we're taking somebody with those features that we have in our new data point. What is the likelihood of them walking? And then we've got the right side. So we're going to talk through each one of these as we calculate them. But for now, let's just give them their names going from right to left. So this one on over here is called the prior probability. And we're going to calculate that first because it's the easiest to calculate. Next one is the marginal likelihood. And we're going to calculate that second. The third one is a likelihood. That's just the names that they have, and we're going to calculate that third. And finally, what we're looking for is called the posterior probability. We're going to calculate that fourth. All right, so that's our plan of attack for step one. This is all still step one, to calculate the probability that somebody walks given those features X that we see in our new data point. Next, we're going to have step two, where we're going to calculate the probability that somebody drives given those features X that we see in our new data point. And again, here we'll have the prior probability, which we'll calculate first, then the marginal likelihood, then the likelihood, and then we'll get to posterior probability. And finally, we're going to compare the probability that somebody walks given features X versus the probability that somebody drives given features X. And then from there, we'll decide which class to put that new data point in. So as you can see, the naive Bayes classifier is a probabilistic type of classifier because we're first calculating the probabilities, and then based on probabilities, we're assigning a class. All right, so are you ready to perform these steps? It's going to be lots of fun. We're going to take it nice and easy, nice and slowly, so that we understand everything. And after this, you're going to be very comfortable with the naive Bayes classifier. Step one. All right, so here we have our visualization. Let's move it all to the left a little bit so we can make some space. Now we're going to calculate the first probability in our Bayes theorem. We're going to calculate the probability that somebody walks. Right, just the overall probability. And what does that mean? That is the probability that somebody walks without knowing anything about them. So we're just saying we're going to add a new observation to our data set into here, but we don't know their age and we don't know their salary. We're just going to put it somewhere into our data set. What is the probability that this person that we're adding to our database walks to work? Well, it's very easy and straightforward. From here, we don't have much choice. The only thing that we can do is calculate the number of red observations, the number of people that actually walk, and divide by the overall number. So probability that a person walks to work without any other knowledge is the number of walkers, number of people that walk, which is these red dots, divided by the total number of observations, the green dots. So the gray dot isn't participating in these calculations. So here we have probability if somebody walks is 10 red dots divided by 30 dots overall. All right, so that was easy. We've calculated the prior probability. Next, we're calculating the marginal likelihood. And this is where things get interesting. So how do we calculate the marginal likelihood? Let's have a look. Here's our data set again. And the first thing that we're going to do is we're going to select a radius and we're going to draw a circle around our observation, like that. Now this radius, you need to select on your own. You need to decide for your algorithm. This is going to be like an input parameter into your algorithm. You can select it less, you can select it more. It's up to you. Now, what does this radius do? Well, what we're going to do is we're going to, first of all, just to make things easier, we're going to remove our dot for now, just so that it's not confusing us. And then we're going to look at all the points that are inside this radius. And what we're saying here is that all of the points inside this circle.
Don't be confused while drawing this circle. So you can draw any circle with how much radius, that is your wish. So you can draw a circle with these 3 points only, whether you can draw a circle with these many points, whether you can draw a circle with this much bigger radius. So whatever the thing you want to draw, you can draw that thing.
We're going to deem them to be similar in terms of features to the point that we had. The point that we had, remember, it had an age of, for example, 25 and a salary of $30,000 per year. So now we're going to draw a radius around it. And let's say anybody between the ages of 20 and 30, and in the salaries of $25,000 to $35,000, anybody that falls in that circle, again, it's not a square, it's not just a square, it's a circle. Anybody who falls somewhere in that vicinity is going to be deemed similar to the new data point that we're adding to our data set. So as you can imagine, this radius is actually going to have a big say in the way your algorithm works. Well, let's say we have this radius, and this is how it all played out. We have 3 red dots, 1 green dot in there. All right, so now what do we do? How do we calculate the probability of x? And what is the probability of x? Well, the probability of x is the probability of a new point that we add to our data set being similar in features to the point that we actually are adding to our data set. So basically, it's the probability of that new point that we're adding, or like any random point that we add, it's the probability of that any random point to fall into this circle. And P of x is calculated as the number of similar observations, so the number of observations that already we can see in this circle, so 1, 2, 3, 4, divided by the total number of observations, which is 30. So P of x is 4 divided by 30. Once again, just to reiterate, P of x tells us what is the likelihood of any new random variable that we add to this data set falling inside this circle. And it is 4 over 30 because we only have 4. Based on prior knowledge, we can tell that there's 4 here and there's 30 in total, so it's 4 over 30. All right, so that wasn't hard at all as well. We calculated the marginal likelihood. So far we've got this one and we've got this one. Next, we're moving on to the likelihood, and this is probably the most complex one. What is the likelihood that somebody who walks exhibits features X? Well, actually, after we've spoken about the marginal likelihood, calculating the likelihood won't be as complex. So let's have a look. So there's our chart. And now what we're going to do is we're going to draw the same circle again. And once again, we're going to remove the gray point for now, and we're going to color our circle. And so anything that falls inside the circle is deemed to be similar to the point that we're adding. So the question is, what is the probability that a randomly selected data point from our data set will be similar to the data point that we're adding? So basically, what is the likelihood that a randomly selected data point will be from this circle, given, this vertical pipe means given, that that person walks, that we know that that person walks to work. The other way to think about this is we're only working with people who walk to work. So we're only working with the red dots, which represent people who walk to work. So let's forget about the green dots. They're faint, and we're not even talking about them at all. We're only talking about the red dots. So the question is, given that we're only working with the red dots, what is the likelihood that a randomly selected data point from our data set, from the red dots, is somebody who exhibits features similar to the point that we are adding to our data set? So basically, what is the likelihood that a randomly selected red dot falls into this gray area, into this circle? That's what the question we're asking. And that's also very simple. Now that we know how all of this works, it's basically the number of similar observations among those who work. So the number of red dots that actually fall inside this red circle, in this gray circle, that's 3, divided by the total number of walkers. So total number of people who walk to work, and that is 3 over 10. There we go. So that's our P of the likelihood of somebody exhibiting the feature similar to the data point that we're about to add, given that we're only selecting among the red dots. So that's 3 over 10, and that was our likelihood. So now if we plug all that in, so there we go, that the likelihood is done. So if we plug all of that in, we'll get our posterior probability. So 3 over 10 times 10 over 30 and divided by 4 over 30. So if we calculate that, it'll give us 0.75. 75% is the probability that somebody that we put into the place where we're putting X should be classified as a person who walks to work. That was step 1. It was pretty intense, right? Pretty exciting to calculate this value. Now, the next step is step 2. That's step 1 done. Next step is step 2, to do the same thing for the likelihood that somebody with features X will be classified or should be classified.
So here it is a binary classification problem. In the binary classification, what happens? We will have only two categories, either yes or no. So here, if we calculated the probability for walkers, so that is we got as 75%. So if we have two, so probability range entirely lies between 0 to 1 only. So here one category belongs to 75% means another category should belongs to remaining 25%. Means in this example, walkers probability is 75% for their specific data point. That means remaining 25% probability lies for this drives. That means that specific points belongs to the walkers category. So here you might aware of simple formula, that is probability 2 equals to 1 minus probability 1. So directly we can do that thing. Whereas coming to here, he is calculating the probability for this drives also. Again, if you do same thing by using formula also, you will get same 25% only.
As a person who drives to work. And here I'm going to throw you a challenge. I'm going to challenge actually the ability of the probability of X being.
He calculated same thing for this second one also. For this, he got probability as 25%.
In a person who drives to work is 25%. So that was step 2. Now we're going to do step 3. We're going to compare the probability of somebody with features X, the probability of them being a person who walks to work versus the probability of somebody with features X being a person who drives to work. So it's 75% versus 25%, and therefore the first is greater than the second, and therefore it is more likely that that person with features X is going to be a person who walks to work than the person who drives to work. So still a 25% chance that that is a person who drives to work, but percent chance that it is a person who walks to work is greater, 75%. And therefore, we're going to classify this point as a person who walks to work. There we go. That is how the naive Bayes algorithm in machine learning works. I hope you found this tutorial useful. I'm pretty excited and pretty proud.
So that is about the working of naive Bayes algorithm. So here it is about the binary classification problem. So from this topic, you interview questions will be, first question will be why it is said as naive. So here we are following the Bayes theorem. That's why it is said as Bayes model. Why we are saying this one as a naive Bayes model. So that is one interview question. So for that simple answer is, so here we need to take independent assumptions. So coming to this model, so if you observe this video, I will play this video once again at the starting. So here, if you observe the,
Hello and welcome back to the course.
if you observe the,
Our new
so here, if you observe this model here, age and salaries. So here on this age, the salary is somewhat linearly increasing. That means here we have dependency between this age and salary. Here we have dependency between this age and salary. And whereas coming to the Bayes theorem, this feature should be independent. This feature should be independent. So though we're not following the exact assumptions of naive Bayes, that's why that then also it is giving good result. Though we are not following the assumption of all Bayes theorem, again it is giving good accuracy or good outcome. That's why it's said as naive Bayes algorithm. So here next question will be, what happens if more than two categories or data is present here? What happens? On such cases, we need to find three conditional probabilities. So here out of three conditional probabilities, we need to find two probabilities. After that, we need to find one more probability that is based on the probability condition. Again, P3 equals to 1 minus P1 plus P2. Simply we can find the probability for the third data type like that. So whatever the thing have more probability, we need to categorize the data point to the specific category. That is the next question. So first question is why Bayes this model is called as naive. So why naive term is added to this thing. So we will see one project corresponding to this thing. So here I'm not modifying the previous project. So whatever the things we did for the previous project, whatever the data set we consider, I'm taking same data set. So here same steps we need to do here also. Initially we need to import essential libraries, and here also I'm working on the social network ads only. So here in this data set, how many columns we have? So here to observe that thing, I want to see the head. That is nothing but first five columns of the data set. So here, if you observe this data set, here we have user ID, gender, age, estimated salary, whether the person purchased that specific product or not. So I want to observe the entire data set. So here in this data set, we might have only, yeah, here we have 400 samples. So what we are doing initially, we are taking all these samples. After that, we are dividing our data set in the form of training and, inputs as well as outputs. After doing that thing, we need to split our data set in the form of training and test set. So again, we need not to perform feature scaling here. To visualize the graph in faster manner, we need to perform feature scaling. Remember one thing, feature scaling is must and should required for SVM, support vector machine algorithm only. For all these classification models, it is not required. Whereas if you want to visualize the all the graphs in faster manner, we need to perform feature scaling. So here we divided our data set in the form of training and test set. After that, we splitted our data set. After that, we performed feature scaling to perform visualization in faster manner. After that, so here what we need to do, we need to import the model. So here from the naive Bayes family, we need to import Gaussian naive Bayes. From the naive Bayes family, we need to import Gaussian naive Bayes model. After that, we need to create an object with that specific class. Here I'm not specifying any parameters. So directly I'm fitting this model. After that, we need to predict the outcome. So here I'm predicting the output. After predicting the output, I want to observe the confusion matrix. So here, if you observe the confusion matrix, so here it is predicting out of 100 points, it is predicting 90%, 90 points correctly and 10 points wrongly. That is nothing but the accuracy of this algorithm will be 90%. So here by using naive Bayes model, we are predicting the output 90% accurately. After that, I want to visualize the graph. So if you visualize the graph, so here it is purely smooth surface of Gaussian. So here we are getting the surface that is contour is smooth curve. So here it is about training data. After that, if you want to test the same thing for test result, so here it is about test data. It is about visualization of test data. It is about complete naive Bayes model. With this, we finished this entire supervised learning session. In the tomorrow's class, we will start unsupervised learning. In the unsupervised learning, we will discuss k-means clustering as well as hierarchical clustering. After finishing the clustering concept, we will see the sentimental analysis. So based on the restaurant reviews, how to predict whether the given review is positive review or negative review, such kind of things we will do in natural language processing, that is sentimental analysis. After finishing that sentimental analysis, we will discuss deep learning concepts, that is artificial neural networks as well as convolutional neural networks. After that, we will move to the artificial intelligence topic, that is computer vision package. So how to perform different operations on the image. We will discuss that thing in computer vision package. While discussing the computer vision, we will discuss that thing. But as the end of the session, so at the end of the session today, I will explain you. So in which cases we need to choose which algorithm. So based on the data set, how to choose a optimum algorithm. So for that purpose, so here I will explain you the things. So for choosing an optimum algorithm, initially, first we need to observe the data set. First feature, we need to observe the data set. So based on the data set, we need to say whether that is in labeled data or unlabeled data. First, initially, based on the data set, we need to say whether it is in labeled data, whether in the data set we have labeled data or unlabeled data. Labeled data is nothing but, so whether the inputs and outputs already specified in the data set or not. So whatever the problems till now we worked, there we have output column also. Initially, we need to observe whether we have output column or not. So if we have output column, so in the data set, if we have output column, that is said as supervised learning problem. Initially, we need to divide our problem in the form of whether it is supervised learning problem or unsupervised learning problem. So based on the data, if the output column is present there, we need to categorize that data is belongs to supervised learning. So after that, if there is no output column, we need to judge that column as in that data set as an unsupervised learning problem. So unsupervised learning, till we did not discuss it about that thing, keep aside. So now let assume we have output column in the specific data set. That is nothing but supervised learning problem only. So after that, we need to observe the output column clearly. So after observing output column, whether the output is magnitude value or categorical data. So whether the output is magnitude value. So if it is a magnitude value, that is nothing but regression problem. So if it is a output is magnitude value, that is a regression problem. If output is magnitude value, that is a regression problem. If output is categorical, if output is categorical, that problem will be said as classification problem. So here that will be said as classification problem. So here till now we discussed a lot of algorithms for regression as well as classification also. Let assume, so here if you have output like continuous values, let assume you are working on temperature prediction only. On such cases, what we need to do? On such cases, if output is the continuous value, that is 100% regression problem only. On such cases, you need to observe the features. Features are nothing but inputs. If your inputs is continuous, if inputs are features, if inputs are features are continuous values, if inputs are features are continuous values, we need to say, so here if input or features are continuous values, so we can apply linear regression model, or we can apply support vector regressor also. So here, if the inputs are features are continuous values, we can apply linear regression model or support vector regressor. If inputs are features are categorical values, if inputs are features are categorical values, so in the inputs itself we have categorical data, then better to go with the decision tree regressor. Categorical, then better to go with the decision tree regressor. So again here we need to check one more thing, whether the input features are continuous. Again we need to check one more parameter, that is if input is how input is depending on the output, whether there is a linear relation or exponential relation. If there is a linear relation, simply apply this linear regression model. So whether it is a simple linear regression or polynomial regression, multiple linear regression based on the input features. After that, if the relation between input as well as output, if it is in exponential manner, then apply polynomial regression model. So here, if your input features are categorical, then better to go with the decision tree regressor, or here we have one more regressor, that is random forest regressor. Or else based on your problem, you can apply all the different algorithms. So wherever you are getting best accuracy and which model giving output in faster manner, you need to consider that specific algorithm for your problem. So here it is about the regression model. Coming to next thing, if your data is in categorical manner, what we need to do? Again, you need to check same thing. If your features is categorical data, so here if inputs are features are categorical manner, that is nothing but either male or female, such kind of categories are present in inputs, whether the country names present in the inputs, such kind of things present in the algorithm, then you need to consider first. Initially you need to apply decision tree classifier. So if it is not sufficient, if it is not giving proper accuracy, then next better to go with the random forest classifier. After that, So after observing the input data, if it is not linearly separable manner, if it is not in the form of linearly separable manner, then better to go with the support vector regressor, support vector classifier. And the next, if your input data is very high, so if your input data is very less, if it is a binary classification problem, if your input data is very less, that is nothing but training data is very less, then better to go with the k nearest neighbor classifier. So whereas if you have confusion to apply any machine learning algorithm, on such cases you need to do one thing, that is apply different machine learning algorithm, observe the accuracy. After that, observe one thing, that is which algorithm giving output in faster manner. Based on those features, we need to fix our machine learning algorithm. So here now, those who are interested to do their project with the machine learning, they can start working on their project. So here projects, so dataset will be available in Kaggle website. You can search the datasets in Kaggle. Whereas before that thing, choose a standard IEEE paper or